Welcome back to geometry class. This is the lesson for Friday, March 20th. Let us begin in prayer. In the name of the Father, Son, and Holy Ghost. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread. Forgive us our trespasses, as we forgive those who trespass against us. Lead us not into temptation, but deliver us from evil. Today's topic is reviewing radicals. What you did yesterday was solve Pythagorean theorem problems. What you noticed there was that you often got an answer that involved a square root. Well, that leads us to the question of what is a radical? A radical is simply a number that you have to multiply by itself a designated number of times to get back to where you started from. Okay, let us take an example. Square root of 25. So what number can I multiply by itself to get 25? We would all recognize that to be the number 5. Let us take another example. What about the cube root of 8? Now I'm looking for a number that I have to multiply by itself 3 times to get the number 8. That answer would be 2, because 2 times 2 is 4 times 2 is 8. I can also take the 4th root. The 4th root, say 81. Now I'm looking for a number that I can multiply by itself 4 times to get back to the number I started with, which is 81. Okay, what would that number be? I heard somebody say it. Good. That number would be 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay? So this is the radical symbol right here. Okay? Notice there is no number here. Well, that's because in mathematics, it is understood that if there's not a number there, it is the square root, or the number 2. We're looking for a number that if you multiply 5 by itself 2 times, you get 25. If there's actually a number there, that tells you that you have to multiply your number by itself 3 times to get back to the number you started with, 8. There's a number like 81 to the 4th root. I'm looking for a number that if I multiply it by itself, remember 3 to the 4th means 3 times 3 times 3 times 3. That would be 81, which is the number I started with. Okay, so that's what a radical is. In this next unit, we're mainly going to be concerned about this guy right here, just taking square roots. But I introduced the other ones because you will visit those next year when you get back to an algebra-based course. So it's kind of good to have an overall perspective as to what is a radical. But square roots are the guy that we're going to be looking at in the next month or so. To better understand radicals, I'd like to give you a factory example just to put it into perspective for you. Think of this as a factory that I work at. Only at this factory, what I'm doing is I'm multiplying everything that comes into my factory by 2, and then I'm sending it out. So if 2 comes into my factory, what would come out? 4. That's pretty easy. You just multiply it by 2. What if, say, 4 was to come into my factory? Again, I would have to multiply it by 2 because that's what my factory instructions are, and I would send 8 out. Now what I want you to think about is let's go through the factory backwards. Okay? It's like building a car. You take some materials. If the factory built a car, it would take those materials and what would it output? A car. Okay? A factory could do that. But could the factory then take that car and put it through the factory backwards and break it up into its individual pieces? That might be harder to do, but you could do it. Okay? Often in mathematics, the opposite operations are more difficult, just like taking that car apart. If 4 goes in here, we multiply it by 2 to get 8. Well, think about if 8 is what came out of the factory, let's go backwards, which is often harder to do, And the question is, what would have had to come into the factory to have 8 come out? And you would all say, well, 4, because you know that 4 times 2 is 8. But what I would like you to think about is, what did you have to do to the 8 to get the 4? And what you would have had to do is the opposite of multiplication. What is the opposite of multiplying something by a number? Division. Okay, so we actually divided by 2. The opposite of multiplying by 2 is dividing by 2. We all understand that. We've been solving one-step problems with multiplication and division for a while now. But let's apply that now to a radical. I'm going to change my factory. Okay, my factory is no longer multiplying things by 2. My factory is now squaring things. So whatever comes in, okay, your factory is going to square it and then send it out along its way. So again, if 2 is squared, 4 comes out. Well, that happens to be the same as 2 times 2, because 2 squared is the same as doubling a number. But what if a different number came in? Let's say 3. Okay, this is where you're going to see the difference. When 3 comes in, if you square 3, you do not get 6 here, because 3 doubled is 6. That's 3 times 2. What I want to do is square the number. 3 times itself. 3 times itself is 9. Okay? So now I'm working at this factory that's squaring everything that comes into it and then sends it out along its way. The question now is, what if I have 9 and I want to know what had to come into the factory to give me 9? Well, 3. We can all say, oh yeah, 3 had to go into the factory. Well, let's ask that same question. What did we have to do to 9 to get back to 3? And the answer is, we had to take the square root of 9. Okay. So what we see is that the square root is the inverse operation of squaring something, just like dividing by 2 is the opposite operation of multiplying by 2. In other words, division is the opposite of multiplying, and square rooting something is the opposite of squaring something. Or radical functions are the opposite of what? Power functions. Okay, whether you're taking it to the second, third, or fourth power, the opposite of expressing something to a power is a radical. Now, let's take a look at this example just a little bit more. Let's say, let's have a more complicated number come in. Let's say 2 radical 2 comes in. What's going to come out? Well, I have to take 2 radical 2 or 2 square root of 2. You'll hear it written expressed both ways. And you have to do what? You have to multiply it by itself, which means I have to multiply it by itself. I'm squaring it. This number times itself. But remember, that is the same. This is all multiplication. I can rewrite that as 2 times 2 times the square root of 2 times the square root of 2. 2 times 2 is 4. Square root of 2 times the square root of 2. Well, this is a number multiplied by itself is 2. I'm multiplying it by itself, so it's 2. So what comes out is 8. Okay, and sure enough, you could do this on a calculator and you would get 8 to come out. Okay. Well, let's think about what we did down here. I might ask you the question now of, well, if 8 comes out, what had to go in? Well, you might say this because we just did it. But you might also remember that the square root of a number times itself gives you this. So you would say, well, that's easy. It's just the square root of 8. Because I know the square root of 8 times the square root of 8 is 8. Because that's what the definition of square root is. When you see this symbol, you're looking for a number multiplied by itself to give you 8. I'm taking this number and multiplying it by itself. So square root of 8 times the square root of 8, you could think of it as the square root of 64, which is 8. Okay. So that tells me that this and this must be two ways of saying the same number. Okay, we're going to see that this is the simplified version of this. Okay, and that's what we're going to look at next. The main thing I wanted you to understand here is if you take a number and square it, you get a number that is the squared number here. If you take that number and you take the square root of it, it takes you back to where you started. So in other words, the square root is the opposite operation of squaring something. Okay, that's the main thing that I want you to get out of the factory example. So now let's take a look at simplifying radicals. Okay, with the factory example, we showed that the square root of 8 and 2 times the square root of 2 have to be the same number. Okay, now we want to see why, or why does square root of 8 simplify to this? Okay, when simplifying radicals, I often like to think of it as perfect squares will get you out of jail. I think of this symbol right here as being jail. Okay, so right now, 8 is the number in jail. What I'm looking for is a perfect square. In other words, a number I know I can take the square root of. What are perfect squares? Well, they would be numbers like 4, 9, 25. Any number that you can take the square root of, 100, and it come out to be an even number. Okay, that's really what a perfect square is that you can take the square root of it and get a whole number. 100, is that a perfect square? Yes, because 10 times 10 is 100. Okay, 90 would not be a perfect square because there isn't a number that you can multiply by itself to get 90. So I'm looking for factors of 8 that are perfect squares. Well, I can think of one offhand, that being 4. Because 8 is 4 times 2. And 4 is one of those numbers that we call a perfect square. So to get out of jail, you need a perfect square. So 4 is a perfect square. So if I'm going to take it out of jail, I'm going to have to take the square root of it. What is the square root of 4? 2. So this is equal to 2 times, the only thing left in jail is 2. And that is why the square root of 8 is the same as 2 times the square root of 2. Let us take a look at another example. Square root of 72, a bigger number. All right. Are there any perfect squares that factor into 72 evenly? Okay. Well, you might recognize that 72 is actually 36 times 2. If you take the largest possible perfect square, you'll be able to simplify this quickly. 36 times 2 is 72, so these are two ways of saying the same thing. And I recognize that 36 is a perfect square. So if it's a perfect square, I can take the square root of it. I can get it out of jail. So it would just be 6 times the square root of 2. And if you take 6 times the square root on your calculator and square root of 72 on your calculator, you'll get the same answer. But you may not have recognized that high a factor right off the bat in the square root of 72. So square root of 72, you might have said, well, I know 9 goes into 72 because 9 times 8 is 72. And you might have recognized 9 is a perfect square. It's a number that you can take the square root of and get a whole number. So now we can go ahead and take the square root of 9. What is the square root of 9? It is 3. It's a perfect square. It can come out of jail. So I get 3 times the square root of 8. But you might also say to yourself, oh, wait a minute, now I know that the square root of 8 is actually the same as the square root of 4 times 2, because 8 is 4 times 2. Now I have another perfect square factor, that being 4. 4 is a perfect square, so it can come out of jail. So now I already have 3 out here, so it would be 3 times the square root of 4, which is 2, times the square root of 2. Remember, this is multiplication, right? This is multiplication. 3 times the square root of 8. 3 times 2 is 6, radical 2. Okay, so there again, we get the same answer. So whether you see one large perfect square that'll factor all out at one time, or two smaller ones, which is often the case. You won't recognize the large one right off the bat. You'll still be able to fully simplify it down to 6 radical 2. This is what we call the fully simplified version of this radical. We often like to simplify radicals because if you take this in your calculator, you get a number that you can't write on the board because the number keeps going after the decimal place. This is the exact answer for the square root of 72. If you use your calculator and get an answer, it's going to be close to this number, but at some point in time, you're going to have to round it off. All right? So that is simplifying radicals. Let's do a more complicated example just to see how easy this really is. All right, here's my next example, 6 divided by the square root of 18. Okay? So first I look at 18 and I have to figure out if there are any perfect squares that can get out of jail. Well, there is one, 9, because this is 18 is 9 times 2. So my perfect square is 9, because that is something that I actually can take the square root of. And the square root of 9 is 3. This becomes 6 over 3 times the square root of 2. Notice the 2 is left over, but it's still in jail. 2 is still in jail. The 9 gets out of jail because it's a perfect square. So you can actually take the square root of 9 and it becomes 3. But notice this is just 6 over 3. Those are just two numbers. If you saw 6 over 3 without this, you would say that simplifies to what? 2 over 1. So now I get 2 square root of 2. 2 over the square root of 2 looks like it is fully simplified, but it is not. There's another rule in mathematics that we have to follow. No radical is fully simplified if there is a radical in the denominator. Notice this square root of 2 is in the denominator. So I have to get that square root of 2 out of the denominator. How are we going to do that? We're going to use the same trick that we use in math in a lot of cases of multiplying by 1. I can multiply any number in mathematics by 1 and not change it. I get to pick the form of 1 I want. I'm going to multiply by the square root of 2 over the square root of 2. If I do that up top, I get 2 times the square root of 2. Notice this is not a radical, this is a radical. I can't say it's a square root of 4 or 4. It's 2 times the square root of 2. In the bottom here, I have the square root of 2 times the square root of 2. Well, I know that's just 2, because what's the definition of the square root of a number? A number that if you take it and multiply it by itself, you get the number you started with. So now I get 2 times the square root of 2 over 2, and notice my 2's what? Cancel. So this is just the square root of 2. Any questions on how to do that? You'll have some homework problems that mainly deal with simplifying radicals without the radical in the denominator. I'm just introducing this because we'll get to this in about a week or so. So I want you to see this, but your homework won't focus on this. I want you to practice just simplifying radicals where the radical is in the numerator first. But if you were able to understand this, you'll be all set for a couple of weeks from now. Your homework is posted on Blackbaud. It's a handout, and we will take a look at that after the weekend. All right, so I hope you have a good weekend, and we'll see you next week.